Thank you for inviting me, and congratulations for this workshop. It sounds very interesting, and I was asked basically to present the European Chips Act. You know that this is has been proposed on the 8th of February this year, and is now going through the legislative process with Council, with the European Council and the European Parliament in order to get approval. As I will show, certain activities can, from a certain perspective, already start. But basically this was done in a relatively short time. The proposal, in view of the situation that you are very familiar with, that is related to the semiconductor crisis, and its impact that has been witnessed for a large part of the European industry, particularly the most visible ones were on the automotive industry. But anyway, this was due to a number of factors. Of course, the pandemic contributed to exacerbate the situation where you already have an acceleration of demand of digital chips because of the digital transition. In general, as you know, the semiconductor supply chain is not really very resilient because of specific choke points along the chain. You have concentration of production with certain companies, specific companies, and specific regions, and also the fact that there were some geopolitical tensions did not help the situation. So you're all very familiar with this. And the impact that it had also on automotive. On the right side, you can see some examples of that, particularly in Europe. Now, of course, it's important to see what is the current position of Europe in terms of strengths and weaknesses along the value chain. So this is one possible representation of that. Which shows the Europe in blue in the different parts of the value chain. And it's clear that we have certain areas of strength, particularly in equipment, in material. But we have, in terms of European Union, certain dependencies, weaknesses in the area of manufacturing, including back-end manufacturing, so packaging and assembly, as well as in design, because what you see there in IP and design automation, actually, most of the IP is actually with UK companies or companies anyway, but maybe even in Norway or anyway in Europe, there is not much in terms of fabless companies, for instance, and in terms of IP, we do not have a strong position, other than now with a relatively recent acquisition of Mentor Graphics by Siemens. But okay, this is to say, in terms of control of IP, we need to certainly strengthen our position there. Europe is obviously strong in the sectors where, for concerns the industry segment in automotive, for instance, in industrial automation, in security, and in particularly for those type of industries, we see that there is not so much need of very advanced of leading edge, let's say, nodes in terms of digital chips. So we are talking mostly about more mature technologies, and therefore Europe is really lacking for what concerns advanced manufacturing. And because those type of facilities are actually driven mostly by the needs of mobile handsets and computing in general, areas where we do not have a strong industry in Europe as of today, as you know. So this is therefore, the consideration on the value chain does not include the part on R&D, where we actually have areas of strength, particularly, I can say we can say around Europe we have many excellent centers of research and universities. We have been investing through our research programs in Horizon 2020 recently, and now moving towards Horizon Europe with the ERC, with the EIC, and also with our joint undertakings. Now, so far, we had the Excel joint undertaking, which is now has moved to the key digital technologies joint undertaking. Once the CHIPS Act will be adopted, this may be renamed as CHIPS joint undertaking, and we'll come to that later on in my slides. In addition to this, these activities are looking at what we call the technology readiness levels, let's say the lowest part of the technology readiness level in terms of maturity of results from research. We have also a program called Important Project of Common European Interest, that is also covering not only R&I. It also supports activities towards commercialization of results in terms of what FID is called, is actually first industrial deployment. That means that actually we can support everything that looks at commercialization up to production, the first batch of production, test production, let's say, before really mass production kicks in. So this is to say that we have these programs to support R&D in Europe. In general, EU industry also invests more than 14%. Of course, that varies, but generally speaking, is an acceptable amount of investment in terms of R&D. So we can say that the problem actually lies then later on how to exploit the results of R&D. And we'll come to that a bit later. Now, in terms of market evolution, we know that the semiconductor market grows more or less with an average growth rate of 7%, and the market is expected to double by 2030. There are a few drivers for this growth. The key one is the digital transformation, as well as increased semiconductor content in all type of systems. And we see the largest growth opportunities are in the area of AI, edge computing, digital transformation, of course, 5G, 6G, but not only. Also with mature nodes and also with analog components, there is still growth because of electrification of mobility, because of other type of let's say developments in the market. So we need to prepare for that, and this gives an overview of the technology trends that we witness in the different sectors. And now I will not go into the details on each of them, but you are probably quite familiar also with the fact that in automotive we have these two elements of electrification and then the transition towards automation, so increased autonomy of vehicles. So the number of chips per car will increase. So the automotive sector is one of the fastest growing. And since we have strength in this area, we need definitely need to maintain this strength, because this is actually jeopardized, if you like, from different business models that are coming up because of indeed these trends, because of the standardization of certain platforms. Um, Also, we have opportunities in uh, in in the future of telecommunication, particularly on the infrastructure side. We have trends towards 5G in industrial settings, but also going beyond 5G. So in 6G, for instance, we need to be present on the early side of the developments of this new standard, with particularly with the involvement of the semiconductor industry in order to steer standardization, not to repeat the mistakes that were made in the previous generations. And then you have, of course, important trends also in the automation of factories, IoT, robotics, um, um, in healthcare, space defense, and energy. I won't go into the details because of in view of time, but there are important elements, of course, with the new type of substrates, such as wide bandgap type of substrates for the energy transition towards, for instance, renewable sources, and need for secure and trusted chips also in Europe is an important element to take into consideration. So, in general, this was an introduction to say how much we need to have an intervention in this sector, and Europe was felt to, European Commission felt it was necessary to intervene with what we call the European Chips Act. As the President von der Leyen put it, is not only a matter of competitiveness, it's also a matter of tech sovereignty. And so the CHIPS Act is meant to strengthen our leadership in research and technology, but also to reinforce our capacity to innovate in design, manufacturing, packaging of advanced chips, to put in place a framework to increase our production capacity by 2030 with very challenging targets. And this cannot be achieved, obviously, if we don't have the human resources to support this growth. So the skills shortage is an important element. We need to support the development of skilled workforce. And finally, we need also, in order to monitor in order to prevent future shocks in the supply chain, we need to have, let's say, a certain procedure agreed with member states and with the industry on how to monitor the supply chain. So essentially, the CHIPS Act is divided into three pillars. The first one, we call it Chips for Europe initiative, which focuses on building a specific type of infrastructure to move from the lab to the fab, to accelerate, let's say, the process of innovation in the area of semiconductors, and to support the growth of startups and SMEs in Europe. The second pillar is about, well, we call it security of supply, but I mean, it's about expanding manufacturing capacity in Europe. And so far, okay, we had limitation in that respect, and we see what we have done in terms of regulation in order to overcome those hurdles. And then pillar three is about monitoring and crisis response, in terms of monitoring the supply chain. So pillar one, first of all, is about converting the excellent results that we get in research into industrial innovation. Because so far we have been lacking instruments that that really support moving from the lab to the fab. And we have leading research organizations, but often their outcome is not exploited, let's say, at least not within the European Union. And so we need to make sure that there is a better link between research within these organizations and the European industry. And the very important aspect is also the lack of a strong design ecosystem that makes use of the strong results from research and that translated into innovation. That is something where we need also to find ways to support innovative companies in this field. So the Chips for Europe initiative is subdivided in a few activities, in few based on a few objectives that we have identified in this area. One is a virtual platform to reinforce design capacity, so that we basically is a cloud-based collaborative environment that will include IP libraries and EDA tools in order to support companies that want to make use of, essentially to lower the barrier of entry for companies to start designing chips. And the second one is to support the development or further development of pilot lines, of existing pilot lines, or the setup of new ones. Pilot lines for testing new technologies to get to prototype on new technologies and get closer to the fab environment. Another goal is to accelerate the development of quantum technologies, and for use for being used in the context of semiconductors, and that can include, of course, includes quantum chips. And then to create a network of competence centers in order to make sure that there is a collaboration across all the different member states that can get access to the infrastructure we are setting up, such as the pilot lines or the design platform, and that can be the link to the local universities in all the regions, different regions in Europe. Last but not least, this is a specific effort which we call a CHIPS Fund, that is to facilitate access to equity and loans by startups, scale-ups, and SMEs in the semiconductor value chain. This is going to make use of two instruments, the EIC accelerator, by having a specific challenge dedicated to semiconductor companies and quantum, in companies in quantum technologies. So this is will be offering grants up to 2.5 million, but also equity up to 15 million for startups in this field. And then we say for other type of needs, we also have a specific top up of the InvestEU, which is a new instrument that we have at our disposal to support with loans and equity the scale-ups and SMEs in this sector. So companies in the semiconductor and photonics also, I must say, can basically get support for their scale-up plans. Now, how this is a possible graphic representation of the relationship between the different parts of this Chips for Europe initiative, where you see essentially in the center you have the pilot lines, and on top you have the design platform. The users will access basically both through this platform. They can have access the design libraries and EDA tools, and through them they can get access to pilot lines and even the fabs. And then there will be competence centers that would be available to support the users in making use of these tools. And then, of course, all the different suppliers will be involved, including, for instance, equipment suppliers, where you have specific pilot lines dedicated to companies, for instance, that are active in the area of manufacturing equipment. And so this will allow them to develop a virtual prototype, for instance, for technology that are not in the market yet, and also to have exploration, validation of these prototypes also at system level. So the benefits and impact of this pillar one essentially are about an easier use of design tools and libraries for design companies, but also any type of industry, including end user industries. This is, as I said, to facilitate the development of the design ecosystem in Europe, and to strengthen our position in terms of European IP. Other benefits are the possibility to do the testing in the pilot lines, to test and experiment with new technologies and prototyping to accelerate the innovation cycle, and essentially this will also provide an easier, faster access to foundry services. Some of you, of course, are quite familiar with the concept of the services offered by Europractice. So essentially, this platform will be boosting those capabilities, and offering again access to different type of services through a single point of access. And and as I said already, the development, this would support the development for SMEs, lowering their entry barrier and trying to bridge the valley of death that is often a challenge for startups in Europe. Now I'll move to the second pillar, which is mostly about production capacity. We know about the problems that we have in Europe because of the level of investment has remained relatively stable in the last couple of decades, with respect to a market where investment in capacity has grown sharply. As you know, of course, the most advanced, the leading edge fabs now have cost in the order of $20 billion or more. And this increases exponentially with each generation. The investment in Europe has remained rather relatively stable. So that means that our share of production capacity has kept declining over the past 20 years. And another problem is that we have been unable to attract investments also from outside Europe. This is also because of certain regulations. You can consider, of course, the state aid regulation that was looking mostly at competition within Europe. But the conclusion is now that Europe is fully dependent on third countries for production of advanced type of chips, for instance, on FinFET and of course anything that goes beyond that today with GAFET, without any control, of course, on the supply chain, on security, sustainability aspects, etc. So without intervention, there is a significant risk of a further drop in the market share, not only in terms of manufacturing, but also of the full ecosystem. And the necessary intervention means that we need to have a way to attract capital investments, private investments, because production is very capital intensive, as you know. Companies need to face major upfront investments, and some level of setting this entrepreneurial risk is needed, and the government usually intervene to support this first phase. And obviously, semiconductor is of key strategic value. This has been recognized, particularly in the last few years. We have seen, of course, this with different effects on also on protection and on certain global geopolitical aspects. And the main economies have also designed important incentive measures. So we cannot stand still, as we said, because the risk is that a further drop of the European ecosystem in the global scene. So essentially, we come up with a concept which makes use of an article of the European Treaty, because, as you know, we have a legislation which prevents from market distortions in terms of state aid. But in this case, when we have a certain type of technology that does not distort the market because it's new in Europe, we call it first of a kind facility because it's first of a kind in Europe. Then this can benefit from support from the state. There is an article, of course, that in the treaty article 107.3c that says that there can be specific economic sectors that may require specific support. And so we are making use of this in this case because of the specific situation that we have. And we have identified basically two types of facilities that can enjoy this. Integrated production facilities, which is more or less can be identified as the activities of the IDMs, but not only. And on the other side, the open EU facilities, which are usually what we can consider the foundries, but not only, because this covers actually open facilities in different parts of the production chain. So it can also be, for instance, in back-end manufacturing, so in packaging and assembly. Now, I think I will move to pillar 3, which is, as I said, is about the supply chain, basically ensuring that we have a mechanism for coordination between the member states with, of course, input from the industry to monitor potential disruptions in the value chain by monitoring specific indicators, trying to anticipate. Of course, it will not always be possible. In many cases, it's not possible to really anticipate a crisis, but at least to see the first signs and to react to have certain measures that will enable us to react to certain shortages, particularly for critical sectors that are particularly vulnerable in shortage situation because maybe they have limited demand, but they are very important for the proper functioning of our society, such as, for instance, the healthcare or energy infrastructure or defense. We will have essentially in this case a monitoring stage together with member states where we would collect, let's say, through some indicators, some information from the key stakeholders. And there will be a semiconductor board that will be set up with advisory participation of industrial stakeholders and other relevant union bodies that contribute to monitoring the supply chain. In case of a crisis, and there are certain specific situation where we can call that we can call a crisis, then there can be an implementing act, which will call for emergency toolbox that will basically include elements such as gathering of information from the companies about the specific demand and supply of certain specific components, and the possibility for only for these specific critical sectors that I mentioned for priority rated orders. Of course, the possibilities are limited, but we need to have the possibility also to include this against, let's say, the level of support that these type of facilities get from the member states. So there will be, in this case, an intensified coordination with in collaboration with the European Semiconductors Board in order to monitor the situation. So this, in a nutshell, was the overview of all the measures that we have envisaged in the context of the CHIPS Act. As I mentioned, we are now in a phase where we are engaging with in the trialogue with Parliament and European Council to discuss and where necessary adjust the measures being proposed, and we hope to finalize the process by beginning of next year. But in the meantime, activities can already start. So the CHIPS joint undertaking will only get its name once the CHIPS Act will be approved. But in the meantime, the KDT joint undertaking can already start its activities. And the KDT joint undertaking would basically already start looking at activities which are not only bottom up, let's say, the type of projects that the industry is proposing, but also have specific strategic areas where we will have dedicated calls to in areas of technology that we feel are very important, relevant for the European industry, and that also gives us more control in terms of strategic priority, in terms of technologies that we feel will be necessary in the future, such as possibly the ones that you are developing in the context of this project.
Thank you very much.
Questions.
Yeah, thank you very much, Marco. I think it was almost perfectly on time. Do we have any questions? The audience?
Yeah, so that was a really interesting presentation, realised that. Are the UK government involved in the initiative? And are they a key player, or is it only for the EU?
I did not get the question. Can you please repeat the question?
So I think I'll try to rephrase or condense the question. The question was whether the UK government is involved in the CHIP Act
not at the moment.
And organization. Not at the moment.
Not at the moment. The UK government, in case we come to an agreement, may be involved in the joint undertaking. So in that case, there will be the possibility for UK companies to participate in the calls of the joint undertaking.
Just as a similar topic, this is a security thing, I guess, in Europe and America. Would America be good involved as well? Some UK and Americans, at least be informed of what Europe are doing. I'm thinking of particularly Ukraine at the moment. China and the East, the supply chain can't deliver stuff for defense projects. we're in trouble in the defence side of things. So it seems like a UK, US, and European, sort of almost a NATO kind of discussion.
Yeah, this is actually something that I did not touch upon in the presentation because there are so many different aspects. It's a complex regulation, but it includes also aspects of international cooperation. And so we have important relationships with several countries. We can say like-minded countries. And particularly with the US, we have engaged in intense discussions in the context of the Trade and Technology Council, the so-called TTC, which is looking at different aspects, including, for instance, the impact of the Ukraine crisis on the supply chain because of specific material, and not only. So in general, we are indeed looking at how we can collaborate to prevent the impact of potential shortages for our industries. And I think in this context, of course, there can also be discussions with the UK government. That has not started as far as I know, but that is, of course, an open possibility.
Good. Thank you very much, Marco.
You're very welcome.
Do we have any online questions?
No, there was nothing coming in so far. Yeah.
Okay.
Yeah, thank you very much,
Thank
Marco.
you. Bye-bye.